Hi, dear students. Welcome again to Vision Class. Today, I'll be taking you through example of alkanes. In the previous lesson, we talked about the classification of hydrocarbons, and we say that they are classified into three. We have alkane, alkene, alkynes. So then we are going to look specifically at alkanes. So the introductory part for alkane is done. So we're just going to look at the example of alkanes. But one thing, don't forget to subscribe to our Vision Class channel, and at the same time share the links with your friends, brothers and sisters who are currently in Senior 4 in South Sudan. We are following the curriculum of South Sudan. So more about me is I call myself Wow Chemist. Yes, welcome to our channel. Today we're going to talk about the example of alkanes. And in the previous topic, we said that they are named using the prefix and what we call the what? The suffix. And then from there you get the name, then the general formula. So I remember clearly telling us that the general formula for alkane. Okay, general formula for hydrocarbon general is CX H Y. Where we say X and Y, they stand for uh, they stand for any given number starting from one and we continue. So and we also say the general formula. I'm just abbreviating it this to make it sure the general formula alkane for alkanes is given by CnH2n plus 2. So any number given here, you can uh, fix it here and you'll be in position to get that one. So therefore, we are saying that today we are starting with n. So the given n here is 1. So if it is 1, then the prefix here is the mid. Then the suffix is an. Some people call it an. Then from there, you get the name methane. So if it is having one carbon atom, we call it methane. Then the general formula becomes CH4. Now, how did you get this CnH4? We are using this general formula and we say n is given to be 1. So if n is 1, then we shall therefore fix this one here. Then we shall have C1H 2 times 1 plus 2. So therefore we shall get C, then this time this plus this shall get H4. That's how we get this general formula. Similar to number 2, if we have 2 carbon atoms, then the prefix comes the E and then suffix become ANE. So we get the name ethane. Then the general formula is this one. The same thing for ethane, we say it is n is given to be 2. We are meaning this n is given to be 2. So if n is 2, we shall therefore see that if n is 2, we shall see that we shall have C 2. We are using this general formula, and we shall have H, and we shall have 2 times 2 plus 2. So here we shall get C2, H this time this 4 plus this, we shall get 6. So that's how you get it. Similar to this, you just substitute H in this general formula, the given n. Okay, let's try the one of 7, and we see that if n is given to be 7, n is equal to 7, we shall also put in the general formula, and we say C multiplied by 7, we get that. Then get your hydrogens, 2 times 7 plus 2. We shall be in position to get C7H. This time this 14 plus this 16. So this one is for heptane. So we call this one methane, ethane, propane, butane, pentane, hexane, heptane. We continue even if you're assuming n is given to be 8. We have n can sometimes be given to be 8, n can be 9, n can be 10. So 8 we call it nonane. I mean n is octane, nonane, then this one becomes the decane. So therefore we shall be in position to name this thing. But the most important thing here is that we are seeing that from this table, we are seeing a series that differs by CH2. So this unit, when you look at it critically here, the difference between this and this is CH2. From this and this CH2. Why are we saying CH2? Because here you will see I have C4, and here we shall have also H10. So the difference between, let's say I have C5, then I have the C what? Sorry. Then I will have the H12. So when you look critical, the difference between this and this is only by CH2. That's the unit we are talking about. So this one here, these similarities can bring both similarity in chemical reactions. We're going to talk about them. Then also they trend in the physical properties. When you talk about the physical properties, we're talking about the boiling point, the melting point of all these substances. But also there are ways of writing the formula for alkanes. And number one, we say the general formula, of course, is given to be like this. So the question is, how can I write? How can I write that? That's the question. So here I'm explaining, if I have A like this, then A will say it is ethane. So how can I write the what? The general formula for ethane. So general formula for ethane, the moment I say ethane, I will just know N is given to be what? 2. So therefore, the number of carbon atoms, the number of carbon atoms The number of carbon atoms in ethane are what? Are also 2. Then the moment I see ANE, then that means I'm dealing with what? With alkane. So if I'm dealing with alkane, then that means I'll have what? I'll have single bonds between the two carbon atoms. So therefore, we shall have C and the single bond, and we shall have C. So from ethene, we have seen we have what? We have 2 number of carbon atoms. And then because of this, we are saying they have what we call single bond. So if there's single bond between the carbon atoms, it is already indicated, and carbon is supposed to have 4 bonds. So we shall put this like this, we put this, put it like this, put it like this. So in this way, we shall be in position to add hydrogen, shall add hydrogen, we shall add hydrogen here, hydrogen here, hydrogen here, hydrogen here. So when you count this one, you'll be in a position to get exactly this. But this is the structural formula, we're not going here yet. So for us to name this, right there, the general formula for this one, we shall be in position to say the general formula for alkane is simply C2H6. Similarly, let's come to the one for butane. So when you say butane, the moment you see but, that means the number of carbon atoms are what? Are 4. This is very critical. You need to pay attention. The number of carbon atoms are 4. Then this part, it means that they are under what? Alkanes. And if they are under alkanes, that means we shall have a single bond between the carbon atoms. So here, what we need to know is N is given to be 4. That means the number of carbon atoms are what? Are also 4. So I will be in position to say 1, 2, 3, 4. But since we did not reach there yet, I will be in position to say that I will have C, 4. Then now hydrogen, of course. Now how will I determine the number of hydrogens? I'll just come here simply and say I have 1, 2, 3, 4. Then now we're saying there are what? Single bonds here, single bonds, and carbon is supposed to have 4 bonds. So this one we have more 3, we shall have 1, 2, 3, 4. This single bond is shared by this carbon and this carbon. So we shall be in position to have something of that kind. This one is full, this one is shared by this and this, so we shall have something of this kind. Then these carbon atoms here, we are seeing here, shall be in position to have 3 bonds here to make a total of 4. So this one has 4 bonds, 1, 2, 3, 4. This one has 4 bonds, 1, 2, 3, 4. This one has 4 bonds also. We have 1, 2, 3, 4. Then this one has 4 bonds. We also have 1, 2, 3, 4. So we shall be in position to put the what? The hydrogen atoms. The hydrogen atoms, because we said uh, hydrocarbons contain what? Carbon and hydrogen only. So we shall be in position to fill up this thing. So if I'm to count the number of hydrogen atoms, I'll say 1, 2, 3. Let me say 1, 2, 3, 4, 5, of course, 6, 7, 8, 9, 10. So I'll be in position to say here I'll have CH10. The exact thing you're seeing here. So for exam, I'm not going to explain that one now. It's self-explanatory, so just say for exam, I'll just have C. If I say X, then that means I'm dealing with 6 number of carbons atoms, so I'll have 6 here. So when you look at it critically, we'll be in position to say here, number of hydrogen atoms will be 14. So we are done with that example. That's how you can write that. Then also, let's come to the structural formula. How can I write the structural formula for this compound? The structural formula, we are required to write the structural formula of ethane, heptane, and butane. So, this is 2 Roman number 1. How can we write this? That's the most important thing. How can we write this? We say ethane. The moment I say it, that means there are 2 carbon atoms in that molecule. Then the moment I see ANE, then that means there's only a single bond between the what? The carbon atoms. So I'll be in position to say that here I'll have what? C, then I have another C. I'll have C, then I have another C. So if you have this one, this knowledge you have gotten it from the word ETH only. There are 2 carbon atoms. Then from here, I can now start saying there is only a single bond between the carbon atoms. Then now I'll be in position to add the hydrogen atoms in the dealing with hydrocarbons. So I'll have hydrogen, 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 and then here I'll have hydrogen atoms. So when you look at this critical, you now see there are 2 carbon atoms and there are how many hydrogen atoms? We have said 1, 2, 3, 4, 5, 6. So this is the structural formula of ethane. In exam, they can say, write the condensed formula for ethane. You will simply say C2H6. And if they say structural formula, you open up, you draw it in this way. Then we have Roman number. We have Roman number 2, heptane. So the moment I see hept, what comes to my mind is telling me that there are how many carbon atoms? There are 7 carbon atoms. From this knowledge alone, I can say I have 1, 2, okay, break it down. I'll have 1, 2, 3, 4, 5, 6, 7. So if I have 7 carbon atoms, shall now say from this knowledge again, they are falling what? Under what? Alkanes. So that means there are single bonds in these carbon atoms, single bonds, and this one we are saying they are what? They are saturated. You will see how saturated they are with number of hydrogen atoms. So this carbon is supposed to have 4 bonds. This is the knowledge you cannot forget in organic chemistry. So we shall have 1, 2, 3, then 4 with this. Then for this one is having 2 bonds already, 1, 2. Then now we add other 2 bonds to make it 4. This one also the same to this, the same to this, the same to this, the same to this, the same. For this one now it is having 3 bonds. So we make it 4 bonds. So when you count, you'll have 1, 2, 3, 4, 5, 6. Let me put the number of hydrogen atom first. Here we shall have hydrogen atom, hydrogen atom. Here also we shall have hydrogen atom. We shall have all hydrogen atoms shall have. That's why we are calling them. They are hydrocarbons. We shall have hydrogen atom. We shall have hydrogen atom. Then we shall have. So we'll be in position to see that when you have to count, we shall have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, the same thing you're seeing here. So this one become the structural formula for heptane. So in exam, we just said, write the structural formula. I've seen this one, some papers, national exam. They just say it, write the structural formula, assuming maybe pentane, you'll be in position to follow the same procedures. Now, another important thing here is we have Roman number 3. Let me put it up here. Roman number 3. Roman number 3, they say butane. Someone might be trying it somewhere already. So when they say so the first knowledge that I get is that if I have butane, then that means here I have 4 carbon atoms inside this molecule. Then from this knowledge, I will just know there is a single bond. There is that single bond in carbon atoms, and I will just say I'm dealing with saturated hydrocarbons. So what comes to my mind is that I'll say 1, 2, 3, 4. Now, if I have this one, I'll be in position to say that from this knowledge, I have a single bond here, here. Then I'll be in position to put the number of hydrogen atoms. So we have now seen hydrogen atom needs only a single bond. A single bond. So this is the structural formula for butane. If you have to count, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you'll be in position to see that. That's how we can write the structural formula for alkane. Thank you for your time. We'll meet in the next